Welcome to Fascinating Frontiers, episode 33. Today is February 27th, 2026. NASA has overhauled its Artemis program, canceling the Artemis 3 moon landing and adding a preparatory mission in 2027. NASA has overhauled its Artemis program, canceling the Artemis 3 moon landing and adding a preparatory mission in 2027. All right, folks, let's dive right into that big news from NASA because it's shaking up how we're thinking about getting back to the moon in a sustainable way. According to reports from Space.com and Spaceflight Now, NASA is scrapping the original plan for Artemis 3, which was supposed to put astronauts on the lunar surface in 2028, mainly because those timelines just weren't realistic given the delays we've seen with spacecraft development and testing. Instead, under the new administrator Jared Isaacman, they're adding this preparatory mission in 2027 that's all about standardizing the vehicles like the Space Launch System rocket and the Orion capsule, and getting everything lined up for actual surface operations. What I find really intriguing here is the human side of this. It's like NASA is admitting that rushing into a landing could lead to mistakes, so they're focusing on those foundational steps to build a lasting presence on the moon, maybe even setting the stage for habitats or resource extraction down the line. This overhaul, as NASA puts it, is about increasing the mission cadence, meaning more frequent flights to iron out the kinks before boots hit the regolith. Personally, I think this could actually speed up overall progress by avoiding costly setbacks. It's a pragmatic shift that acknowledges the engineering challenges of deep space travel, and it might inspire more international partnerships to share the load. It reveals just how ambitious timelines can clash with reality, but by refining their strategy now, they're opening doors to a more feasible path for human spaceflight, perhaps even accelerating things like Mars missions in the long run. What do you all think this means for the future of getting humans back out there? It's got me pondering how these changes could ripple into the next decade of exploration. Shifting gears to something that's directly tied to making lunar bases viable, NASA just tested a fascinating system for extracting oxygen from the moon's soil. Over at NASA, they've successfully integrated a solar concentrator with mirrors and some clever software in what's called the Carbothermal Reduction Demonstration, and it worked on simulated lunar regolith to produce carbon monoxide. Basically, this is in-situ resource utilization in action, using the sun's energy to heat up the moon's dusty surface material and pull out oxygen, which could be used for breathing or even as rocket fuel. Why does this matter? Well, imagine not having to haul every ounce of oxygen from Earth. It cuts down on launch costs and makes long-term stays feasible, turning the moon into a kind of self-sustaining outpost. The engineering challenge here is huge, getting mirrors to focus sunlight precisely in the vacuum of space, dealing with the regolith's abrasive nature, but this test shows it's possible. I'm genuinely curious about how this scales up. If we can master it, it changes the game for not just the moon, but maybe Mars too, where similar tech could support human explorers. It's one of those quiet breakthroughs that might not grab headlines like a launch, but it's foundational for the future. Now, on a different note, let's talk about some fresh insights from the James Webb Space Telescope, which is peering into the outer reaches of our solar system. Universe Today reports that JWST used its NIR-SPEC instrument to map out Uranus's ionosphere, picking up on auroral bands and variations in the magnetic field. Uranus is this weird, tilted world. Its axis is almost sideways compared to its orbit, and these observations are helping us understand how that extreme tilt affects its atmospheric dynamics, like how solar wind interacts with its magnetosphere. What's significant is that we're seeing these auroral features in infrared for the first time, revealing hidden structures that ground-based telescopes couldn't catch, and it ties into broader questions about how ice giants form and evolve. From a scientific angle, this data could explain why Uranus has such a wonky magnetic field, possibly due to internal oceans or convective layers, and it's a reminder of how JWST is revolutionizing planetary science beyond just exoplanets. I love how this builds on Voyager's flyby from decades ago. It's like filling in the blanks of a puzzle we started piecing together back in the 80s. It makes me wonder what else Webb might uncover about Neptune or even distant exoplanets with similar setups. Definitely keeps the curiosity alive. Speaking of our solar system, NASA's Curiosity rover on Mars has turned up some intriguing clues about the red planet's watery history. As detailed on Space.com, the rover imaged these web-like features in the rocks, which look like they were carved by ancient groundwater seeping through and leaving mineral deposits behind. These spider webs in the stone are evidence of a time when Mars had liquid water flowing beneath the surface, potentially creating environments that could have supported microbial life. Context-wise, Curiosity has been climbing Mount Sharp in Gale Crater, analyzing layers that tell the story of Mars transitioning from a wet world to the dry desert it is today, and this find adds to the mounting evidence of habitability billions of years ago. The human story here is inspiring. Engineers and scientists poring over these images from millions of miles away, piecing together a planetary biography. My take? It's a quiet thrill, reminding us that Mars wasn't always barren, and it fuels the drive for future missions to drill deeper or even return samples. Discoveries like this make you appreciate the rover's endurance. It's been at it since 2012, still uncovering secrets. Turning back to Earth for a moment, researchers have found evidence of an ancient asteroid impact right here in Brazil, and it's shedding light on our planet's turbulent past. Universe Today describes a newly discovered tektite field. Those are glassy rocks formed from melted Earth material during impacts, and this one points to a major asteroid strike about 6 million years ago. The spread of these tektites across multiple provinces in Brazil reveals how far impact debris can travel, giving us details on the scale of the event and how it reshaped the local geology. Why is this significant? It adds to our understanding of Earth's impact history, which influences everything from climate shifts to evolutionary pressures, and it's a reminder that our planet has been battered by cosmic visitors throughout time. From an exploration angle, studying these sites helps refine models for predicting future impacts or even mining resources from asteroids. I'm fascinated by how this connects to broader astronomy. Tektites are like time capsules, and finding them in South America expands the map of known impact zones. It makes you think about the fragility and resilience of life on Earth, doesn't it? Next up, with a total lunar eclipse coming our way soon, I thought it'd be fun to chat about why the moon turns that eerie red during these events. Space.com notes that the eclipse on March 3rd will be the last total one until New Year's Eve 2028, and it'll be followed by a rare trifecta of them in 2028 down 2029. So mark your calendars for a chance to see Earth's shadow fully cover the moon. Astronomy magazine explains the science behind the blood moon. It's all about Earth's atmosphere bending red sunlight into the shadow while scattering away the blue light, much like why sunsets are red. This atmospheric optics phenomenon ties into how particles in our air, like from volcanoes or pollution, can make the moon appear even deeper orange or red, offering a natural lesson in light refraction. What's cool is that observing this from different spots on Earth can reveal variations, and it's accessible to everyone. No fancy telescope needed, just a clear night. I remember watching one as a kid in Vancouver, and it sparked my love for astronomy. It's one of those events that connects us directly to the cosmos without any tech. Plus, understanding this helps explain similar effects on other worlds, like potential eclipses in exoplanet systems. Looking beyond our planet, China is ramping up its space ambitions with some impressive plans for long-duration missions. Space News reports that China will launch its first one-year human spaceflight mission this year, and they'll also host a short visit by a Pakistani astronaut to the Tiangong space station. This advances their goals for sustained human presence in orbit, testing life support systems, psychological effects, and international cooperation, all key for future deep space endeavors. The engineering here is top-notch. Maintaining a crew for a full year means perfecting recycling tech for water, air, and food, building on what the ISS has taught us. From a global perspective, including a Pakistani astronaut highlights how space is becoming more collaborative, potentially paving the way for joint Moon or Mars missions. It's exciting to see China pushing boundaries. Makes me curious about how this could influence NASA's timelines or even lead to shared tech. Finally, let's touch on SpaceX's wild proposal that's stirring up debate in the astronomy community. Sky and Telescope says SpaceX is planning to launch up to 1 million satellites for orbiting AI data centers, but it's raising serious concerns about light pollution messing with night sky observations, atmospheric re-entry impacts, and the growing problem of space debris. This ambitious idea aims to create massive computing power in space, perhaps for real-time AI processing, but the scale is unprecedented, way beyond Starlink's current constellation. Why does it matter? It could exacerbate issues for ground-based telescopes, where satellite trails already interfere with data, and there's an open public comment period right now to weigh in. The engineering challenge is immense, deploying and managing that many SATs without collisions, but it also spotlights the tension between commercial space growth and preserving the cosmos for science. My brief take: it's innovative, sure, but we need regulations to balance it, otherwise we risk cluttering the orbits we all rely on. Before we go, next time we'll be watching for updates on that March 3rd lunar eclipse and any fresh images or insights it brings from skywatchers around the world. That's Fascinating Frontiers for today. If you enjoyed this episode, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for listening, and I'll see you tomorrow.
Drifting softly through the black.